So let's download the latest VirtualBox from the VirtualBox homepage. I happen to be using an OS X host. Next, we'll download Ubuntu. We want the desktop version. And we're going to alternative downloads because we don't want the latest version. We want a slightly older version that's consistent with the version of Ubuntu that's running on the virtual machine that will host the website and the web application. Okay, so that's version 14.04. And just grab the 64-bit version. Assuming that VirtualBox has been installed, let's go ahead and install Ubuntu in a new virtual machine. So we create the machine here, and my laptop has 16 gigs of RAM, so I'll just dedicate a quarter of that to the virtual machine. We don't intend to use the virtual disk with any other software, so we can just use VirtualBox's proprietary disk. And I'll increase the size of the disk just in anticipation of using a lot of video and images directly in the virtual machine. So let's change some settings. We'll need to mount the install disk of Ubuntu on boot, so let's just set the optical disk to be the disk image that we downloaded. We already changed the RAM, and we can confirm here that the optical disk will attempt to boot before the hard disk, which is significant here. We can increase the video memory, and my laptop has 4 logical CPUs, so I'll dedicate half to the VM. And with that, I think we're good to go. So let's turn on the machine. And we can see that we did in fact boot directly into that Ubuntu installer. You can ignore that, that's just my packet sniffer that alerts whenever any software tries to call home. So here let's install Ubuntu, and I'll let you select the preferences that you choose. At this point, I have already completed the installation. This is sort of the final splash screen. And we're ready to restart. Okay, with the machine restarted, let's log in. And we'll choose not to upgrade because, again, the virtual machine that FIU hosts, from which we'll host our web application, runs version 14.04. So we want to make sure that our development environment is also 14.04. And here I just clear some clutter from the launcher and install software updates. Now let's launch the terminal and just check to see what version of Python's installed. And we'll lock that to the launcher for future use. Alright, and as expected, 2.7.6 is what's installed. And so this meets the requirements of the software that depend on Python. So that's good. So now let's download and install virtualenv, and that's short for Python virtual environments, which are useful because they allow multiple projects that have differing dependencies to exist on a single OS without conflicting with one another. So let's search for virtualenv, the latest version, download it directly. In our case, we want to make sure that because Ubuntu depends on its existing Python installation for package management and that sort of thing, we want to make sure that any changes we make, including upgrading the version of Python, only affect our computer vision algorithm development environment and not the system. It's also useful to have virtual environments if you, like me, happen to work on both the computer vision module and also on the web dev on the same machine. You want to keep those two separate. Okay, so let's check out. You can see that I've already extracted virtualenv in the downloads folder. I'm going to create a new directory just to store all of our virtual environments to serve as a parent directory for all of them. And we'll change to that directory and create our new virtual environment for our algorithm engineering. cvdev-env. Great. And to enter the environment, there's a file named activate that we invoke with the command source. So just type source, the environment root, bin folder, and then activate. And now you can see on the left that we're in that environment. So next, we'll grab the project source code from GitHub. So what I'm doing here is just creating a parent folder within which to house all of the Git repositories, right? And that's a subfolder of our home folder. So I'm just going to position this text so that I can read it directly and then directly type the URL into the clone command. And miraculously, we're done already. Okay. So next, we will grab the Opencv library. This is the installation guide on the official web page. You can see at the top are three groups of dependencies, but first we'll just go to the Git repository and get the source code and install from source. We're going to download the source code to the downloads folder. So let's change to that directory and then run git clone. Now, before we install Opencv, we'll install the dependencies that were listed in the blue box on the official installation page, starting with Build Essential. And then there's a second bulk of dependencies that can be installed now, listed here. And then we'll go back to the web page to grab that third list of dependencies and install those. And here I just install matplotlib and scipy, which are dependencies of the Scikit-Learn machine learning library, and also scikit-image, which does a little bit of computer vision tasks, and mainly we use to read and write images from and to disk. So we'll install those dependencies here. So next, we can build Opencv using the directions on the web page, including making this release folder, and then the build options that you saw just copy and pasted in bulk are in the final deliverable document of the Fall 2016 Senior Project. There's a user guide that you can follow in addition to this video to get those flags. You can see here that the installation location is our virtual environment, so that's good to see. So first we'll run make to build and link. Sorry, second we'll run make. First was cmake, second was make, and third we'll run make install in order to actually copy the contents that were compiled and linked to the local lib folder. And notice that I executed this command as root using the sudo prefix. And next, we'll need to add the path to Opencv to the Python path environment variable so that we can import the library in Python. And in order to avoid having to do this every time we enter a new user session in the terminal, I'm just going to add this command to the bottom of the bashrc file that's in our home folder. It's a hidden file that's prefixed with a dot. And this script gets executed on every new user session login. And in the background, you can see the document that I previously mentioned, which is a part of our final deliverable submission. Right. So to make sure that this change takes effect in our existing user session, we need to source that bashrc file, right, to invoke it. and then that actually kicks us out of our environment, the virtual environment, and so we'll source the virtual environment's activation file in order to get back in, to sort of reactivate the environment. So let's just confirm that we can import Opencv, and we did successfully, so that's good. And next we'll install Scikit-Learn. And again, this is the machine learning library that implements the histogram of oriented gradients, feature descriptor, and the support vector machine linear classifier that are used to detect the long-end fruits in the long-end detector. And then we'll also install scikit-image, as previously mentioned. All right, now let's also confirm that we can import these two libraries. So that's scikit-learn, scikit-image. Okay, great. Now we're ready to download the Pycharm IDE. And before you launch Pycharm for the first time, after downloading it, you'll want to register an account with JetBrains, and that account is free for students, but it gives you permission to use this professional version that I'm downloading here. It gives you license to use it. Okay, so let's just unarchive Pycharm. And I've previously created a subfolder of my home folder named optbank, opt_bank. And historically, optbank is a folder where user-specific applications are installed. And so in keeping with that tradition, I'm going to install Pycharm and its dependencies in this optbank folder, which is a subfolder of my home folder. And so you can see it there. There's Pycharm. Inside of a subfolder named bin, there's a pycharm.sh script that you can run in order to launch the application for the first time. And you're immediately prompted to activate the software, and which is why you want to go ahead and register in advance. It looks like I have a typo in my password here. Okay. And so on first launch, you're prompted to select some settings. There's a dark theme named Darkula that I prefer. Okay. And for the changes to take effect, we're required to enter the root user password and also to restart the software. So upon restart, you'll want to add the application to the launcher, like permanently lock it to the launcher. so that we don't have to run that shell script every time we want to open Pycharm. With that done, we can create a new project where we specify the location to be the project folder for agricultural robotics, right? That Git repository that we cloned previously. So I'm going to the home folder here, and then our GitHub subfolder, and our project, right? So that's our location, and we confirm that Python 2.7 is the interpreter, right? That's correct. And that's required, unfortunately, because scikit-image is not written for Python 3 yet. So the entire project is bound to Python 2.7 because of that one dependency. But anyway, we can just look through the structure here and see that the contents are consistent with what's in the file system. And the last thing that I want to comment on that's not illustrated in the video is in the VCS menu at the top there, you can enable version control with Git specifically, and then use the Pycharm IDE to um, manage all of your pushing and pulling and merging and committing and all of those things very conveniently from the graphical user interface. And that's it.